Let's look at lesson 64, talking about complex fractions and complex numbers. Well, example 64, 1, it shows this problem. Now this, here, it actually has a 1 plus in front of it, but what I want to show you is that's all that these complex fractions are adding. It's just adding that right there. In the past, we have solved for this. This is already a complex fraction. Now it's just making it a complexer fraction. So how we start is basically cover this up and cover the top up. And we're going to start by solving for 1 over b plus x. Well, how we solve there, and that doesn't look too difficult, right? That's easier to solve. So what we do there is we do our least common denominator is b. This one needs a b, so we add it to the top and bottom. And now we can add these two together. I'm going to do a lot of erasing on these to save space. So 1 plus xb over b is what we get to. Now we got to get rid of our fraction in the denominator. That's no bueno. That's not simplified. So multiply by reciprocal. To top and bottom, b over 1 plus xb. So now everything crosses out. And we get 1 times b is b over 1 plus xb. And then I bring down this one. So we got a bunch of that done. Now we're here. Now this basically looks like, well, if I rewrote the problem, it looked like, well, this right here basically looks like that. How did we solve? Least common denominator. Do the same thing here. Least common denominator is 1 plus xb. So we multiply this side times 1 plus xb to the top and to the bottom. And so, yeah, you distribute the 1. So you get 1 plus xb plus b, and you can add them all together now in the numerator because they all have the same denominator of 1 plus xb. And that's how you ultimately do complexer fractions. That's what it should be called, complexer. Let's do one more example. 64-2, same thing. Let's look at the bottom first. Look at the bottom denominator of the fraction. 1 plus b over x. Its common denominator is x. So we do x over x. And when we add those together, that equals x plus b over x. X plus b over x. And now we have got to switch reciprocal x over x plus b. Now remember, the 4 is still over 1. So since the 4 is over 1, you only distribute the 4 to the top. Distribute the top to the top, bottom to the bottom. So we get 4x over x plus b, not equals, plus a over x. Find our common denominator to add these complex fractions. And our common denominator, remember, if it's a sum in the denominator, it's its own identity. So our common denominator is x times x plus b. All right? And we do that on the sides. So when we multiply everything by x times x plus b, these x's cross out. We distribute an a, so we get ax plus ab. Our denominator here is going to be x times x plus b. And over here, the x plus b's, sorry. Yep, my bad. whoops, x plus b's cross out, and you multiply 4x times x, so 4x squared. So there's your very long unorthodox answer. ax plus ab plus 4x squared divided by x times x plus b. So that's complex fractions. Now we're going to look at some complex numbers. Say you had 64.3, negative 3, radical whatever times radical negative 2. If you had a guess on how to do this, I think you would guess right. You multiply the radical 3 times radical 2 and get radical 6. Now this doesn't actually this is not your answer. What it actually, you actually are doing this. Radical 3 I, because of the negative, times radical 2 I. And so those i's become I squared when you multiply I times I. Now if we know our wheel of i's, I is square root of negative 1, 2i's is negative 1. I'll go ahead and finish it off here because we're going to need it in the next few problems. But I squared is negative 1. So if this is negative 1, we move this negative on this side and write our answer like so. So that's how that is what your answer would be there. Negative radical 6. Now let's look at adding some, or simplifying some complex numbers. We have this situation here. What we want to do is look at all of these i's. Let's go left to right and just see if we can simplify each of these individually. 4i cubed. Well, I cubed is a negative I. So that's going to become a negative 4i. I to the fourth is just a 1. So imagine crossing that out, so negative 2, because negative 2 times 1 plus 2, and we got this situation of a radical negative 9. What does that become? Well, we take out the negative to make it radical 9i, and then the square root of 9 is 3. So that becomes times 3i. We can go ahead and simplify that to be 6i. 2 times 3, 6i. Then we have this situation here, kind of like what we had in our last example problem. Square root of negative 3 times square root of negative 3. Well, square root of 3 times square root of 3 is square root of 9. Negative and negative, those become I and I, so square root of 9i squared. We simplify that. Square root of 9 is 3. I squared is a negative 1. So this is all a negative 3. Hopefully you could see that there. Now we just combine our like terms, negative 2 and negative 3, doing the whole number first, because you want the whole number first to be complex numbers, plus 2i. And that is your example simplified. Negative 5 plus 2i. One more example. We're just learning how to use these imaginary numbers. They're nothing special. They sound complicated, but they're nothing. This one wants us to multiply. So, if you had a guess, you're probably guessing right. You FOIL. So we do our first. 4 times 3 is 12. And then we do our outside. 4 times negative 2i is negative 8i. Then we do our inside. And that would be positive 6i. And last, 2i times negative 2i. Well, that would be a negative 4i squared. Well, what does I squared become? Our wheel of i's says it is a negative 1. So negative 1 times negative 4, and you get positive 4. 12 minus 8i plus 6i plus 4 add your like terms, 12 and 4, get our whole numbers first. 16 minus 2i is your answer. All right, so that's how you do that. Those are complex fractions and complex numbers. I thought I taught that great, so y'all make sure to subscribe to my YouTube channel, Stuart B501. Follow me on Instagram. Make sure to subscribe, tell your friends about me. I'm out.